Hi students, this is Ms. Johnson with 8.2-4, Changing the Starting Point. Today we are going to be making tables, graphs, equations, and determining if situations are proportional. I need you to have out a piece of paper and your math books open to page 398. Alright, on page 398, it says, you will now explore a situation in which runners start a race at different points. You will see how rules and graphs show these differences. Develop and understand Part A. Alida. Alida ran a race with her younger sister, Olivia. Alida let Olivia start 4 meters ahead of the starting line. That's so nice of her. Alida ran at a steady rate of 3 meters per second, while Olivia ran at a steady rate of 2 meters per second. Alright, we're going to do 1 through 6 today, so follow along with me and get your paper set up and ready. Question number 1 says we are going to make a table to show how many meters each sister was from the starting line at various times. So go ahead and pause the video, copy my table onto your piece of paper. Hopefully that only took you 2 minutes or so. If not, you need to copy a little faster. Alright, so we're going to make a table here to find the distance that each child was. So let's start with Alida. And Alida is the older sister, and she is going to let Olivia start 4 meters ahead. So that means Alida is going to be right here at the starting line. She's going to be starting at 0. Alright, then we need to figure out how far she is after 1 second. Well, it says in the book that Alida ran at a steady rate of 3 meters per second. So if 1 second goes by, it's 3. If 2 seconds goes by, 3 times 2 is 6. 3 seconds go by, another 3 meters, 9. Go ahead and fill in the rest of the table. Yeah, go ahead, fill it in, don't wait for me. Alright, then you should have 12, 15, 15, 18, 21, 24, 27, and 30. Alright, Olivia, the younger sister, she gets that 4 meter head start, so she's going to start at 4. Okay, then it says back in the book that she runs at a steady rate of 2 meters per second. So she's going to go up by 2 meters. So if we're at 4, she's now going to be at 6. Going by 2s, it's now 8, then 10. Go ahead, pause the video, keep going, filling in the numbers. And there we go, filling in, Olivia gets up to 24 meters. Alright, question number 2 says, on the same grid, we are going to draw a graph for each sister showing the relationship between distance from the starting line and time. Then we're going to compare the graphs. Alright, let's go ahead and set up a graph. And we're talking about running, so I'm going to put my title of running up on top. Time is going to go down on the bottom because time just keeps going on, and their distance is going to be along the side. Alright, taking a look at time. Well, as we look at our table, our time went from 0 to 10. So on our graph, our time needs to go, again, from 0 to 10. So make sure you start at 0 and number going across up to 10. And you want to number the grid lines, not the spaces, but the grid lines. And there you go, all the way up to 10. Alright, the numbers for distance. Again, we need to take a look at our table. And Alida and Olivia's distance, let's see, Alida gets the furthest at 30, so we need to have our graph go up to 30. So, let's see, how do I want to go up to 30? Well, we could go by 3s, we could go by 4s, it doesn't matter. We could even go by 2s if we wanted, but I'm going to go by 3s. So I'm going to go 0, 3, 6, 9. Go ahead, keep labeling all the way up to 30. And there we go, all the way up to 30 going by threes. All right, so we're going to graph each sister, and with Alita, I'm going to graph hers in red. So taking a look at the table, she starts with 0 time, so I'm going to go to 0 seconds for time, and she starts at 0, so I'm going to put a dot. Then 1 second, so I'm going to go across to 1. She went 3 meters. Okay, next point is going across to 2 for our seconds and up to 6. Okay, go ahead and pause the video, go ahead and keep plotting all of Alita's information from the table. And you should notice now that you are done that the dots go in a nice steady pattern because she is running at a steady rate. Alright, now for Olivia's. I'm going to graph Olivia's in green. And looking at Olivia's table, at 0 seconds Olivia's at 4. So 3, and I'm going to have to estimate that 4 is about right there. Then at 1 second, so I'm going to go across to 1, she's at 6. So right there. Continuing along at 2 seconds, she's up at 8. Okay, pause the video, go ahead, keep graphing Olivia's data. And there we go. Here is Olivia's. Hers also makes a nice straight line because she's running at a steady rate of 2 meters per second. All right, moving on to question number 3. It says, is Alita's distance from the starting line proportional to time? Is Olivia's distance proportional to time? Well, remember, proportional means they start at 0. So whose is proportional because she starts at 0? Correct, it's Alita. So let's write this down, and I'm just going to fill in my name because I have it all set up. Alita's is proportional because she starts at 0. So whose is not proportional because she doesn't start at 0? Yes, that's obviously Olivia. All right, good job. That's number 3. Number 4. For each sister, write a rule in symbols to relate the distance d and the time t. And how are the numbers of rules reflected in the graphs? All right, well, let's go ahead. Number 4. And I'm going to get you set up. To find Alita's rule or formula, we're going to have d equals, because that's what we're trying to find. They're trying to find their distance. Those were the numbers we filled in the table. So d equals something t plus something. And Olivia's is going to be d equals something t plus something. All right, what we want to do is we want to take a look and go back to the beginning. It says, Olivia ran at a steady rate of 3 meters per second. So Alita ran her distance. She went 3 times the time. So 3 times a second every time, plus, where did she start? She started at 0, so it's going to be plus 0. Olivia, her distance is Olivia ran at a steady rate of 2 meters per second. So hers is going to be 2 times t, plus, where did she start at? She started at 4, so it's going to be plus 4. Okay. Remember, whatever is added or subtracted is the starting point. And let me slide this down. Let's go ahead and put this note. Whatever is added or subtracted is the starting point. That is our y-intercept. All right, let's move over to page 399, and we're going to talk about some brothers. 5 brothers. If I read right underneath Develop and Understand Part B, it says 5 brothers ran a race. The twins began at the starting line. Their older brother began behind them and behind the starting line. Their 2 younger brothers began at different distances ahead of the starting line. Each boy ran at a fairly uniform speed, meaning a fairly constant speed. Here are rules for the relationship between the distance d meters from the starting line and the time t seconds for each boy. All right, so we've got Adam, and Adam has the equation d equals 6t. Brett has the equation d equals 4t plus 7. Caleb has the equation d equals 5t plus 4, David, d equals 5t, and Eric is d equals 7t minus 5. Well, let's practice this proportional stuff. Which ones of these are proportional? Well, just a reminder, we talked about Alita's being proportional because she starts at 0. So, which ones of these brothers start at 0? Well, we look at whatever is added or subtracted. So, Adam is proportional because his equation is 6t plus nothing. So the plus 0 means that's where he starts. David is also proportional because his equation is d equals 5t. Nothing is added, so there's really a plus 0. Excellent. All right, number 5 is we need to figure out which brothers are the twins. Which brother is the oldest? All right, well, we need to go back to the paragraph that I read, and the twins, it says the twins began at the starting line. Well, which ones did we just talk about were at the starting line? Yes, Adam and David are at the starting line. They both started at 0. So the twins are Adam and David. All right, the other part of this question is to figure out who is the oldest brother. Going back to the paragraph, it says, their older brother began behind the starting line. So Brett, Caleb, and Eric are our 3 guys that are left. Which of those 3 began behind the starting line? If you said Brett, you are wrong. If you said Caleb, you are wrong. The correct answer is Eric. And we can tell by looking at Eric's equation that he's the oldest brother, that he started behind the starting line because of this minus 5. He was 5 meters behind. So the older brother is Eric. All right, question 6. It says, for each brother, describe how far from the starting line he began the race and how fast he ran. I want you to go ahead, pause the video, and copy down this setup for number 6. It has each brother, and it says Adam started blank from the starting line and ran blank meters per second. Go ahead and pause it. All right, now that you have this done, we can get all this information from our equations. And the starting line, if we go to Adam, we already know that Adam started at 0, because that's what's added or subtracted. The other number, the 6, the number that's in front of the variable always tells us our rate, always in this case tells us our speed. So Adam ran 6 meters per second. All right, let's do one more together. Brett started at 7, because that's what's added or subtracted. And he ran, how fast did he run? Yes, he ran 4 meters per second. Go ahead and pause the video and fill in the other 3 boys. All right, you should have figured out that Caleb started 4 meters from the starting line because of the plus 4, and he ran 5 meters per second because of the 5 in front of the variable. You should have figured out that David started at 0, and he ran as well 5 meters per second. And you should have figured out that Eric started at -5, 5 meters behind the starting line, and he ran 7 meters per second. Excellent. Good work today. This is 8.2-4. All right. Homework for tonight is on page 406. It's numbers 7 through 12 and number 20, doing very similar things to what we just had in the video. Thanks for tuning in. See you later.